Well, this is the result we are after, the quartz. And we are going to create the interior damage, surface damage. Yeah. So let's see in Houdini. First, we use a tube, and then we just boolean with a dodahedron. So we can have this kind of quartz-like structure. And we transform the top and bottom and scatter some points on the surface. And then we use Voronoi fracture. And we remove the inside because yeah, we are not interested in the inner surface. And we are going to cluster these primitives, but I don't like the Voronoi cluster because we can see this is the Voronoi cluster, but it's kind of uniform. So we wanted to do the clustering by ourselves. So we scatter some points and cluster by position. So we can see our cluster. We generate a cluster attribute on, I think it's on, yeah, it's on points, but we promote the cluster attributes to the primitive. And by the way, the name attribute, the piece, this is the cluster generated by Voronoi. Yeah, and then I just loop through every one of the cluster I created and poly extrude. And yeah, and before the loop is just fetching the piece and the cluster with my cluster attribute. And the important point is that we have to fuse it because the Voronoi might, it might be fractured. So we fuse it first and then poly extrude it. Okay. Then we subdivide to add more detail to our geometry. Then I just create a group, this group, and for the upper vector, we just use a noise to create more interesting detail, just simply advecting the position by y. So we use the position and with a turbulent noise, add it to the y. Yeah. So here comes the key point, using the sign distance field to create this kind of damaging effect. Which is pretty hard, I think, to manually sculpt it in the ZBrush or other 3D modeling software. And with Houdini, we can create this very easily. Or even this kind of magic pattern. Yeah, like this. But our goal here is to create this kind of damaging effect. All right. And the key idea is VDB with a sign distance field. And then we calculate the gradient, basically a vector perpendicular to the position of the surface. And then we use a volume VOP. And here comes the key idea. If we just let's say we grab the original position and import our SDF and wire in the result, it would be the same surface, right? Because we are basically just resampling the volume, the sign distance field. But the key idea is, what if I distorted or add a noise to this sampling position? So we are going to use a noise, basically a 1D noise. We are going to scale it with multiply the noise with the gradient. So we get the gradient, and multiply with the noise. So we got a vector. This is a 3D vector gradient, and we add it into our sampling position. So we use this to sample. Voila, we got this kind of crazy result. And I'm also using a mask here, so we could remove the mask so we can see this, yeah, kind of crazy result everywhere, but I use a mask. So the damaging effect is just, yeah, this is the mask. Nothing special. Just use a, yeah, just use a position and then use a ramp so we can, yeah, it's kind of like a GANs function. We can tweak it and just, yeah. So yeah, that's basically it. So we can create this kind of interesting damage effect. I see many people use the density, the volume density and then a volume valve and create something. I think this kind of, it really doesn't make sense unless you are trying to create some cloud or some pyro. Because think about it, this is this density field, a 1D density field. And inside, if you just, let's say I multiply it with a noise and output the density, yeah, it doesn't really make sense. And you can see inside we have got this all kind of degenerated geometry. This is very bad. All right. So yeah, I think the correct way is to use a SDF with a gradient. Yeah. And because we are trying to, we use this, we might get some small floating pieces. Yeah. So we use a measure and a wrangle to remove, to keep only the largest pieces. And then finally, because they're all melted together, so let's use the Voronoi again to break up the geometry. So scatter some points, Voronoi. And then use updating interior detail to create this kind of detail. Without interior detail, it's, yeah, we need to create additional geometry. So when the light is refracted or reflected inside, we've got interesting result. And then we just kind of blend this kind of two result together by using a noise. So we get this kind of a partially fractured geometry. I like the geometry here. Yeah, that's basically it. The cars. So we can just make this as a digital asset. And yeah, we can tweak all this, all kind of, create different kinds of cores. And let's look at the base. Basically, it's the same. Basically, we've got an input geometry. And then using the same technique, oh, I'm not using a volume SDF here. Basically, I'm just using the sub-level modeling tool. Use a mountain to create some detail. VDB, smooth the geometry, and using the van sub, basically use it to displace our geometry, so we can get this kind of really natural rock layering effect, kind of a layer after a layer. Yeah, I like this result a lot. So this is the input, we've got the output. Yeah, and in sub level, actually, we could also use sub to model something. But if you want extra detail, I would suggest, yeah, using the volume for crazy detail stuff. Okay, and we have 100% of control. And in the final phase, I also use the volume technique. So this is input, and again, I convert it into a SDF, calculate the gradient using the technique I just previously said, and voila, we get a kind of this rocky, crazy structure. Okay, this is, I think this is the basically the whirly noise f2 minus f1, very useful for creating rock, this kind of small rock. Yeah. Yeah, so we just scatter it on the surface. Another thing I want to talk about is intersection analysis. So let's see. Let's say I scatter some geometry using the proxy, the low resolution one, on the surface of this rock. I scatter it on it, and I wanted to check the intersection. So basically, we use the easiest way is to use a for loop to loop through every one of the pieces. And it's a feedback loop, so we fetch one piece and fetch the feedback and use intersection analysis to check if we have intersect with anything. So if anything is intersected with the previous pieces, this guy will output something. So we use a switch. If we have intersected with something, the number of points will greater than 0. So we should not grab the new pieces. Otherwise, we should grab it. So we create a group. So we can see that we can remove the colliding pieces. Okay. Let's say this is non-colliding. So this is colliding. If we remove these pieces, we are no longer colliding with our geometry. And after that, because I have created an index ID for each of the pieces, so I know which the pieces that's left. So we have this ID, and all I need to do now is to grab the original points. Each point has an ID, so I just compare it with the result. So I know which kind of points needs to be removed. So we can, simply loop through the CPID, the ID, and then now we can use these points to copy the high resolution one. So we simply, let's see, where's the high resolution? This guy, yeah, high resolution ones. Because basically you don't want it to do the intersection analysis on the high resolution one. Your computer will explode. All right. Yeah. And then just use the guide with the hair to create this kind of fur structure. Yeah. So basically this is it. And the result is here. Yeah. See you.